Hey guys, Miss Paraso here again for you. This will be the last set of guided notes that we have for this unit, and it is on rotations. So by now we should have done the rotations discovery or at least watched the video and had a discussion about this stuff in class and about what we noticed. So I'm going to be referring to this as we go through our notes. So a rotation is a type of transformation that involves a figure turning or rotating about a certain point, right? And the center of rotation is where it's turning around. It's the fixed point that it will turn around. So for us, our center of rotation is going to be the origin. So when I was using the transparency in the discovery activity, I put my finger on the origin and moved it. So you can rotate figures around a point, you can rotate it around itself, but our focus for this unit is rotating around the origin. So, and then also in the discovery activity, we talked about counterclockwise and clockwise and making some connections there. My focus, I tend to focus on 90 and 90. If you just remember that 270 is that they end up being the opposites of each other. As long as you refer to 90, there's a trick for helping to remember the rule. All right. So counterclockwise is going to the left. All right. And in this case, when we were going 90 degrees counterclockwise, we saw that the 3 and the 4, they switched places. And now the new x variable coordinate, sorry, became the opposite sign. So if we think about it, okay, if this is my trick with the 90, they switch places 90 degrees counterclockwise, draw your arrow. Which one is it pointing to? It's pointing to the x. So it means take the opposite of that new x value. So here we are going to switch the coordinates, and you're basically multiplying the new x value. Okay, I'm going to be writing a y, but it's because they switched by -1. So whatever coordinate I have, I'm going to switch them. So the y is now in the x position, and the x value is now in the y position. So it's still a regular coordinate. I'm just showing you that I switched their values. And again, 90 degrees clockwise means that this one is going to become the opposite. So it's the new x value becomes the opposite. That's why you're multiplying it by -1. All right. And then we also saw that 270 clockwise was the exact same rule. So if you memorize at least one of these, just know that 90 is the same as 270 clockwise, so the opposite direction. That can help you out with the applying the rules as well. All right. So we're going to go ahead and switch the coordinates, and we're going to multiply the new x value by -1. So again, switch the coordinates. So they're going to switch places, and then the new x value is going to take the opposite sign. Does not mean it's always going to be negative, because if it was originally negative, then it's going to become positive. All right, and we're going to see that in a little bit. Alrighty. Then we're taking a look at 270 counterclockwise. So in our discovery activity, again, the 4 and the 3 switched places, but now this time the new y value became the opposite. So if I'm looking at 90 clockwise, if you think about it, 90 clockwise is one turn to the right. Okay, and notice it's pointing to the y value to signal that, hey, pointing to this one, this is the one that needs to change. So we're going to switch the coordinates again, but this time we're going to multiply the new y value by -1. So they're going to switch places, and this is in my y position. Yes, it says x, but I switched them around, okay? And I'm going to multiply my new y value by a -1 to take the opposite sign, okay? And that was the same thing for 90 degrees clockwise. So I forgot to put my arrow up here. Clockwise is going to the right. So in this case, it's going to the right 3 turns. This is just 1 turn to the right. So we're going to switch the coordinates and multiply the new y value by -1. So switch them, and that one becomes the opposite, right? And then in the 180, we can see that the 3 and the 4, They stayed in the same positions, except now they were the opposite signs. So this time you're going to multiply, we don't need the word the, multiply both coordinates by -1. And remember when we did the dilations, when we multiplied by negative, it turned the figure. So it turned our image. So let's see here. There it was. So it turned it. In this case, because it's multiplying it by a 1, the shape, the size doesn't change, but because it's negative, it rotates it 180 degrees. All right, so the X and the Y here do not switch. They just become the opposite sign of whatever they were. Alrighty, so let's just, for example, just take a look at what it looks like in one single point. Now, you're not going to see anything being turned per se. So let's see here. Let's do something like, we'll go over 2, 1, 2, 1, 2, 3, 2, 3. Well, let's make a line segment. Maybe kind of a diagonal. Let's go down 1 and over 1, 2, 3. So this is A, this is B, and we'll draw a line. Okay, so that's 2, 1, 2, 3, and 5, 1, 2. Okay, so if I wanted to do a 90 degrees, again, counterclockwise, if I was going to go counterclockwise, that means I'm going to go to the left. And you will see me drawing these arrows frequently because I always have to remember which way I'm turning. Okay, so when you're going to rotate on a coordinate plane, if the image is already on here for you, the best thing, a piece of advice I can give you is to write down the original coordinates, 2 and 3. And we have, what did I say, 5, 2, okay? And I would actually apply the rule. You have to remember that with 90 degrees or a 270, the X and the Y are always going to switch. So that's the first thing. So what I would do here is I'm going to do A prime, and I know that they have to switch. But if I can't remember which one becomes negative, that's okay. Let's just go ahead and switch them up first. All right. So you've got two things. Well, because we're going 90 degrees counterclockwise, so again, I'm doing a 90 degrees counterclockwise, okay? I'm going to draw my arrow going to the left, so that means the one on the left becomes the opposite. So that one's going to become negative. The other way that you can think about it is if I'm in quadrant 1 and I'm going 90 degrees counterclockwise, well, this point is going to end up in quadrant 2. And the X value is the negative value here. So that's going to become the negative, and the Y value is still positive. So that can also help tell you your sign. So if you ever need to just kind of draw a little map, you're like, okay, I was here and I'm going 90 degrees here. So this is a negative positive combo. All right. So we'll practice that a little bit in class. So negative, I find it easier just to write out my points and apply the rule. So -3, 1, 2. This is A prime. B prime is -2, 1, 2, 3, 4, 5. Again, because these graphs are horrible here. B prime, A prime. Okay, and you can see how it turned. All right, and this would also be the same as if it were a 270 degrees counterclockwise, because then I would be doing this. 270 counterclockwise, not, sorry, just kidding. 270 counterclockwise would end up over here. All right, I'm going to focus on just the 90 counterclockwise. Okay. All right. So let's take that same set of lines. So we had 2, 3, 2, 1, 2, 3. That was A. And 5, 2. That was B. And there's our line segment. Okay. And now this time let's do 90 degrees clockwise. All right. So 90 degrees clockwise, that means we're going to be going to the right. And we're turning it one time. So again, if A was in quadrant 1 and I'm turning it clockwise, it's going to end up in quadrant 4. Oh, sorry about that. Hate those little pop-ups. Okay. Alrighty. So it's going to end up in quadrant 4, and that's where we want to kind of make sure that that's where we end up. So again, that kind of helps you figure out, well, what are my new coordinates going to be? So again, I had 2, 3, and 5, 2. Those were my original ones. Now with a 90 degrees or a 270, I have to flip-flop. Okay, so my A prime, I'm going to flip the positions. Okay, but then one of them is going to become the opposite. Well, because it's clockwise, I'm going to end up in this quadrant here. My Y values are in the negative values, so that tells me that this has to become the opposite. Okay, or again, you can use the arrow trick. It's going to the right, so pointing to the one that should become the opposite value. All right, so B prime, we're going to switch them, and then this becomes the opposite sign. So we have 3, -2, and 2, 1, 2, 3, 4, 5. All right, don't forget to label them, A prime, B prime, and we can see that. Okay, now I'm going to tend to refer to always 90 degrees counterclockwise and clockwise. That's my preference. I just always know that 270 is the same except just in the opposite direction. Alrighty? Okay. So on this side, what you're going to want to do is, this is where you want to practice applying the rule. Now, the only thing is that it did not tell you the direction, so I'm going to tell you which way I want you to go. I would like you to do, all of these are counterclockwise, so 90 degrees counterclockwise. 180 doesn't matter. 180 doesn't matter. So a 270 counterclockwise. All right, so just to give you an idea, again, a 90 degrees counterclockwise means we're going to go to the left, and I'm going to write myself a note that reminds me, oh yeah, I have to switch them. Okay, so that means that I'm going to switch the 9 and the 2, and then because I'm going to the left, the X value is going to become the opposite. So again, here, the 3, -5, they're going to switch places, right? You're like, Ms. Paris, so you left a negative there. I know I did. I like to do the baby steps. So I'm going to switch them, and then I'm going to take the opposite of this value. So the opposite of -5, I'm just going to turn that into a +5. That's my visual to let me know that I applied that rule. Okay? So same thing here. I'm going to switch them. 2 and -8, they switch places, but then I got to take the opposite of that X value. Okay? I'll let you finish up the last 3 on your own. All right, so you're going to do the same thing. Apply the 180 rotation. Remember, there was no switching in this one. And then 270 rotation counterclockwise is the same as a 90 degrees clockwise. So go ahead and pause the video and see if you can apply the rules to find out where the new location would be for those coordinates. And then check back in when you're ready. All right, take a look and see how you did, and also see how I did. Make sure there's no teacher challenges. I think I did it right. Okay, so again, 90 switch, and the X value became opposite. 180, we're going to keep them, and they just become the opposite of what they were. And then the 270 counterclockwise was the same as 90, so we switch them, and we take the opposite of the Y value this time. Okay? All right, and so for the last section, you're going to want to go ahead and do the same thing that we were doing on the front with the line segment AB. I recommend writing out what were your original coordinates. So here we have -3, 3, V is -2, 3, and Q is -2, 1. And then actually apply the rule to the coordinates and then graph them. So that's my recommendation to you. All right, so go ahead and pause the video and then check back in to see how you did. All righty. Oh, and I did not draw these in. My bad. I forgot I was supposed to draw them in there. But here's what your new coordinates should be. So give me a hot minute. Let me get right back to you. Let me draw those in so you have a visual to make sure you have the drawing right. All right, my bad. Here you guys go. There's the image. You can see that I worked out my points and my new coordinates. And we can see that the shapes, they are still the exact same size. They have just been turned. So rotation is another one where the shape stays congruent. The side lengths stay congruent, whereas like dilations, they were similar. The angles were the same, but the side lengths were proportional. Okay. So then there is my messy work for this one. And again, you can see I do my counterclockwise.